Welcome back, students. We are now doing ratios, module 2, lesson 2. Calculators are allowed in this lesson. We are going to figure out how to express one quantity as a ratio of another. Now we are going to look at some simple principles that will help you solve commonly asked problem sums involving ratios. So once you've understood these principles, you should be ready to start scoring. Okay, the objectives of this lesson. Objective number 1. Expressing one quantity as a ratio of another given the fraction. Number 2, expressing one quantity as a fraction of another given the ratio. And thirdly, find how many times one quantity is as large as another given the ratio. Okay, let's jump straight into these problem sums. Question 1, students, the number of red pens is 1/5 the number of blue pens in a desk caddy. What is the ratio of the number of blue pens to the number of red pens to the total number of pens? Step 1. Let's draw the models. Let's draw a simple model to illustrate the information given. You've got one red pen, right? And the question says 1/5 of the number of blue pens is a red pen, right? Red pens represents 1/5 of the number of blue pens. So how many blue boxes will there be? There should be 5, right? So we've got the model done up, so that is step 2 now. Based on the model, we can easily find the ratio needed. The order is this: blue is to red is to total. Now how many blue boxes do we have? We've got 5 blue boxes is to how many red boxes? 1 red box. What is the total number of boxes? 6. 5 is to 1 is to 6. And that is your final answer. Okay, let's move on. Question 2. The ratio of the number of girls to the number of boys in a class is 4:5. Girls is to boys is 4:5. Question part A. What fraction of the number of boys are girls? And part B is what fraction of the class are boys? So let's do step 1. Step 1 is to draw a simple model to illustrate the information that is given to us. Number of girls, 4 units, right? So let's draw a model, 4 boxes. Because by drawing these boxes, we get all the information we want to answer the questions. Number of boys, 5 boxes. That's what the question says, right? 4:5. Right, now let's look at step 2. Just by looking at the diagrams above, let's find the answers. Part A, what fraction of the number of boys are girls? There are 5 units of boys, 4 units of girls, so the answer is 4/5. Can you simplify that any further? No, so that becomes your final answer for question A. Question B, what fraction of the whole class are boys? So there are 5 units of boys, but to find the total number of units in a class, you add up all the boxes. So you get 9. So the answer is 5/9. Once again, how did I get 9? You just add up all the boxes. 4 boxes for the girls plus 5 boxes for the boys. You get 9. And these are your final answers. Question 3, students. Peter is 3 times as old as his brother Andy. Part A of the question is this: what fraction of Peter's age is Andy's age? Part B of the question is: what is the ratio of Andy's age to the total age of the brothers? Okay, now let's write it up. Let's do step 1. Let's set it up. As always, when it comes to ratios, one of the best things to do is to draw a model to illustrate the information given. Peter is 3 times as old as his brother Andy. So 3 boxes for Peter. Let's draw a model. Peter is 3 times as old as Andy. So Andy has how many boxes? Andy is in orange. Andy has 1 box. Okay, now simply look at the model and let's answer all the questions based on the model. Okay, part A is this. Part A is: what fraction of Peter's age is Andy's age, which means is Andy over Peter. So Andy's got 1 box, Peter has got 3 boxes. So it's 1/3, and there you go, that's your answer. Andy is 1/3 as old as Peter. That's your final answer for part A. Part B is this: the ratio of Andy's age to the total age of the brothers. So the ratio of Andy's age. Andy has got 1 box. Total age of the brothers, 1 box plus 3 boxes, which is 4. 1:4. And that is your final answer. That's it. We're done with question 3. Question 4, students. Mel's father runs 7/3 as far as Mel does. The total distance they run together is 850 meters. Part A of the question is this. Find the ratio of the distance Mel runs to the distance his father runs. Part B is this. How much further than Mel does his father run? Step 1. What are the simple things we can identify? Who runs the longer distance here? The father runs the longer distance. Okay, so let's draw the units up. The fraction given to us is 7/3. Am I right? So the father has how many units? The father has 7 units. What about Mel? Mel has 3 units. Absolutely right. 7/3, right? 7/3. Okay, now based on this information, what are the information has been given? The total distance covered is 850 meters, right? So now let's answer part A first. And that is going to be real easy because the model is right there for us to follow. What is the ratio? Mel is to father. So Mel is to father is 3:7. And that's your answer for part A of the question. What about part B, step 3? We've got to find what is the information we have to find. How much further than Mel does his father run? So you can see that the father runs 4 units further. But the total number of units equals to 850 meters, right? So 10 units equals to 850 meters. So what is 1 unit? It is 850 meters. 850 meters divided by 10. So 1 unit equals to 85 meters. The father ran 4 units further than the son. So 4 units equals to what? 85 meters multiplied by 4. What do you get? You get 340 meters. And that is your answer for part B. And you're done with question 4. Question 5, students. 3/5 of Ali's money is twice as much as Junie's money. Part A of the question is this. Find the ratio of Ali's money to Junie's money. Part B, if Ali has $49 more than Junie, how much does Junie have? Now, to tackle a problem like this, the best thing to do is to start drawing the models. Okay, you can see that Ali has 5 units. Okay, you've got to keep in mind that twice of Junie's money is the same as 3 units of Ali's money, which is actually 5 units. So let's draw the 5 units. And let's shade the 3 units, right? Let's shade the 3 units. Now let's draw Junie next. Okay, 3/5 of Ali's money is twice as much as what Junie has. So that's 1, and the next one is an imaginary one to illustrate twice as much. Okay, from here you've got to find the ratio. Now think about it. If you want to find the ratio, you've got to simplify the model, right? And the best way to simplify the model in this case is to cut it into half, to cut each of those boxes into half. So let's do that. Let's cut. So Ali's money becomes 10 little boxes. Now what about Junie's money? 3, right? Because the other one is imaginary. Okay, now, part A, Ali is to Junie, right? Look at the diagram and you get 10 boxes is to 3 boxes. And that is your answer for part A. Now, moving on to part B. If Ali has $49 more than Junie, how much does Junie have? Now, think about it. The extra boxes represents $49. Let's draw that into the diagram, okay? The diagram. Okay, let's draw that. See, the extra 7 boxes, that's $49, right? Because it says Ali has $49 more than Junie. So that is more than Junie, 7 boxes more than Junie. So if 7 units is equals to $49, what is 1 unit? Back to units again, right? $49 divided by 7, and you know the answer for that one. That's going to be $7. So if 1 unit is $7, Junie has 3 units. Junie has 3 units. 3 units is going to be 7 times 3. That's going to give you $21, and that is your final answer. Junie has $21, and the ratio is 10:3. Well done. Alright students, we've completed ratios lesson 2. I know this was a slightly lengthy one, but I had to cover all 5 questions. Go ahead and attempt the quiz, and as always, go score.